Hey guys, so today we are doing the first part of conditional statements, and this is like the book If You Give a Mouse a Cookie. So if you've seen that, or I guess read it in your elementary, then you kind of know what I'm talking about. There's if you give a mouse a cookie, if you give a moose a muffin, there's a lot of different ones that they've done before. So, conditional statements, we're going to refer to the conditional statement as your original statement. And conditional statements are written in an if-then format. So, if this happens, then something else is going to happen. So your hypothesis is considered the part after the word if, and then your conclusion is the part after the word then. So we could use like the word, your hypothesis is your subject. What are you talking about? And then that could be like your noun. And then your conclusion is the action part, what's happening, or maybe that verb. So if it's raining, then it's cloudy. So that could be our first conditional. What I want you to do on all of your assignments is underline the hypothesis one time. So if it's raining, it is raining is considered our hypothesis. Notice I did not underline the word if. So you're going to underline your hypothesis one time. And then your conclusion is it is cloudy. And I want you to underline your conclusion 2 times. So underline your conclusion 2 times. And when you do that, it's going to help keep that information separate, because we're going to learn what's called the converse, inverse, and contrapositive, and that does some rearranging of what's considered the hypothesis and what's considered the conclusion. So on this next one, we have a sentence, a car with poor brakes is a menace on a highway. And so we want to create this into a conditional statement, which is an if-then statement. And before we do that, I need to first identify what's considered the hypothesis and what's considered the conclusion. So the subject matter, what are we talking about? We are talking about a car, specifically a car that's got poor brakes. So my subject of my sentence, my hypothesis, is that I have a car with poor brakes. And I'm going to conclude when it's got poor brakes, it's going to be a menace on the highway. So we'll double underline the conclusion. It says underline it twice. So my conclusion is a menace on the highway. So now we're going to put this together and create a conditional statement. Now, I wouldn't say if a car with poor brakes then is a menace on the highway. We want it to sound a little better than that. Remember, I teach math, so I'm not looking for perfection, not an English teacher, but you want it to sound a little better than that. So, if maybe a car 4 breaks. Then it is or it will be a menace on the highway. So if a car has 4 brakes, then it will be a menace on the highway. So our first type of sentence we're going to do is a converse. Converse is not a prisoner's poem, but a converse is going to be formed by switching the hypothesis and the conclusion of your conditional statement. Remember, the conditional is that original. So we had before, if it's raining, then it's cloudy. Remember, it is raining is the hypothesis, and the conclusion is that it's going to be cloudy. So my converse switches them. We're going to say, if it's cloudy, then it's raining. So if it's cloudy, then it's raining. Okay? Now, if I were to take that statement and say, if there's clouds out, does that necessarily mean that it has to be raining? And the answer is no. So we have what's called a truth value, and we can determine that truth value of a statement. And when a statement is considered true, then there are no counter examples that can be provided to disprove that statement. So there's nothing you can do to disprove that statement. Well, if it's cloudy, then it's raining. We know that sometimes there's clouds out and it's not raining. So that would be a counterexample. Now, counterexample is an example that's going to prove your statement false. Now, in order for it to be false, the hypothesis still has to be true. So this is proven by assuming the hypothesis is true, assuming that yes, in fact, there are clouds out, but we're going to show with a counter example that the conclusion is false. So our example would again just be that, hey, it doesn't necessarily have to be raining. Now, counter examples must be something specific. So if I said, all prime numbers are odd, well, we could go back and look at our sieve of Eratosthenes, and remember the first number we circled was 2. So instead of saying in words, not all prime numbers are odd, you would have to be specific and say the number 2 is a specific example that proves that statement false. So counterexamples must be specific, and you only need one counterexample to prove a conclusion false. You don't have to have all of the different counterexamples, you only need one. Now, counterexamples can be just basically a statement where I just said that the number 2 is a specific example, or it can be a diagram, a picture. So if I said all acute angles are 85 degrees, you could draw an example of an angle that's 45 degrees and say, you know, here's a picture of an angle that is not that, so on and so forth. Okay? So right here we have, if an angle has a measure of 120, then it is an obtuse angle. So we're going to first determine the truth value of this one. If an angle is 120, then it has to be obtuse. Well, our hypothesis, an angle has a measure of 120. The conclusion, it is obtuse. That is a true statement. Now, if it's a true statement, then there are no counterexamples needed. So that is my conditional statement. When I switch it up, when I switch it up here, it says if an angle is obtuse, then its measure is 120. That, when we switched it, remember, is called the converse. Now, if an angle is obtuse, is the only angle in the whole world it can be is 120? It can't be anything else? No, that's false. So a counter example could be, an angle with the measure of 110. It could be 150. You could even say 90.1. It's just barely over that right angle. It is still considered obtuse, but it is not exactly 120. So with that being said, a lot of y'all will have different counterexamples, and so I have to go through and read everybody's individual counterexamples because there could be several different types. All right, so now on this other side, we have the negation of a statement. To negate a statement is to say the negation of a statement is the opposite meaning of that statement. So we have what's called the inverse, and the inverse is formed by negating both your hypothesis and your conclusion of your original statement. Remember, the original statement is your conditional statement. So we've been using this example several times. If it's raining, then it's cloudy. The inverse negates that statement. So it stays in order. If it's raining, the opposite would be if it's not raining, then, and we're negating the conclusion. So the opposite of it's cloudy would be then it's not cloudy. Okay, so let's try this again. If school is in session, then it's a weekday. My hypothesis is school is in session. My conclusion is it is a weekday. So the inverse negates that. If school is not in session, then it's not a weekday. So let's think about that. We've got the inverse of that statement, but we can say whether that statement is true or false. So if school's not in session, then it's never a weekday? No, I don't think so. And that's actually these next holidays. Remember, we have Friday off and we have Monday off. So it could be a teacher work day. It could be a holiday. It could be summer. Again, there are lots of different counter examples, but you do have to be specific. Those are some specific ones. And how many did you need? You only needed one counter example. So any of those would be fine. So let's practice this again. We have if a number is not divisible by 2, then it is odd. Ooh, this one's kind of interesting. So when I need to negate, remember negating is taking the opposite of that meaning. So if a number is not divisible by 2, then we could say if a number is divisible by 2. That would take the opposite meaning. Then you can say it's not odd, but another example I want to show you is that, remember, numbers are either odd or even. There's not really an in-between. So instead of saying, then it is not odd, I could change the word and say, then it is even. So you've got some options when you're writing these. So if a number is divisible by 2, then it is even. Yeah, that's actually true. So if it's true, is there a counterexample? No, it's not. Then our last type is called the contrapositive. The contrapositive is formed by switching and negating your hypothesis and conclusion of the original statement. The original statement was your conditional. So you're going to do the converse by switching it, and you're going to do the inverse by negating it. And so when you do both of those things, we now call it your contrapositive. So going back, if it's raining, then it's cloudy. We're going to switch it and negate it. So if it's not cloudy, then it's not raining. Now, if it's not cloudy at all, is it possible for it to be raining? No, it's actually not, because rain comes from the clouds. So what's interesting is that your contrapositive will always have a truth value if your conditional was originally true. Okay? So our last part on here is we're going to take this actually, sorry, we've got one more to practice. Let me go back. If you are running a red light, then you are breaking a traffic law. So our hypothesis is you are running a red light. My conclusion is you are breaking a traffic law. My contrapositive switches and negates. So if you are not breaking a traffic law, then you did not run a red light. So if you did not break a traffic law, it is not possible for you to be running a red light, because we know running a red light is actually breaking it. So the contrapositive should be true, and when it's true, there's not a counterexample. All right, now let's go back to the very end where I kind of skipped ahead. It says students must pass Algebra 1 to graduate. So this is not written as a conditional. So I have to come up with a conditional. In order to come up with the conditional, we have to figure out what is my hypothesis and what is my conclusion. So what is the subject matter? What are we talking about? Our noun, we're talking about students. Then your conclusion is the action part of it. So what is happening? What is our action? The action is that they must pass algebra to graduate. So my hypothesis is maybe not just the word students, but maybe if you are a student. My conclusion, if I'm saying you are a student, my conclusion would be you must pass Algebra 1 to graduate. And I kind of ran out of room, sorry. So I want to put these together and make a conditional statement. So I would say if you are a student, then you must pass Algebra 1 to graduate. Now this part's important. Once I pick my conditional, how I choose to form that sentence, you must stay consistent for the converse, inverse, and contrapositive. And what I mean by that is if you are a student, I wouldn't want to change the converse to if he is a student, if she, if they, or if there are students. We want to stay consistent with the original statement. So, converse, double check over here, our converse is formed by switching. So, when I switch that hypothesis and conclusion, I'm going to say if you must pass Algebra 1 to graduate, then you are a student. Again, we're not adding anything extra to that. We're not saying then you're a student at Martin High School, because I did not mention Martin High School over here. All right, the inverse, checking back up here, the inverse is formed by negating. So my inverse negates and negates. So if you are not a student, then you could say you must not pass, or you could say then you don't have to pass Algebra 1 to graduate. So I altered the sentence a little bit, but not anything major. And our last one is the contrapositive. Contrapositive is switching and negating. So you're doing both of those things. Starting over here, if we take the inverse, we take the opposite. If you don't have to pass Algebra 1 to graduate, then we take the inverse of that, then you are not a student. So all of these are going to help you with that first part of your assignment. And then the last thing that we're talking about is it's called a biconditional. So we've got hypothesis, conclusion. We created it into a conditional in an if-then format. We took the converse by switching, the inverse by negating, and the contrapositive by switching and negating. And so the last part is a biconditional. And a biconditional is when, I get my colors, your original, when the conditional statement and the switched version and your converse statements are both true. So if, when you're writing those going both directions, they are true, then that's called a biconditional. So a biconditional will use the phrase, figure out what color I'm going to use. I'm kind of out of colors. We will do if and only if. And you can shorthand it with IFF, or you can do a double arrow. So, all, and this is just kind of a fun fact, that all definitions can be written as a biconditional. Like, if we know that all right angles are 90 degrees, then you could say, if an angle's a right angle, then it's 90. When you switch it, if an angle's 90, then it's a right angle. Those are both true statements. So I can create it into a biconditional and say, an angle is 90 degrees if and only if it is a right angle. And I think we might see that question either in some of the notes here in just a second, or maybe it's on a quiz or a test. I can't remember where. All right, so we've got on here, write the conditional and the converse. We have a solution is neutral if and only if its pH is 7. So we start off with our hypothesis, And then we use our conjunction word, if and only if, and then our conclusion. So our conditional is the original. If a solution is neutral, then its pH is 7, and that's it. We want to take that biconditional and split it back up to the original if-then format. And then we take our converse, and that's where you flip it. So if, and what are we talking about? What is its? It is the solution. So if a solution's pH is 7, then what? Then it's neutral. Okay. So this next one, if two angles have the same measure, then they are congruent. We want to put that as a biconditional. So instead of the word if and then, we're completely removing them, and we start with hypothesis, if and only if, conclusion. So two angles have the same measure if and only if they are congruent. Now, if it's a math type sentence, then I will allow you to kind of substitute some of those symbols out that we normally use. So I will let you do that. Next, we have if 5x minus 8 is 37, then x is 9. We're going to write this as a biconditional. So we start off with hypothesis, and if and only if x is 9. Again, you can use IFF or you can use the double arrow. I tend to use the double arrow when it's math related. Now, we can determine the truth value of biconditionals just like we determine the truth value of the others. Now, for a biconditional to be true, both your conditional and its converse must have both been true. And if either of those statements are false, then the biconditional will be false. So, kind of think about that really quick here. If x is 9, is that the only equation in the entire world that it could be? No, we know there's lots of other equations. So, going this direction, yes, it's true, but when you switch it going the other direction, that was false. So altogether, this biconditional would have a false truth value. We're going to check them over here. A rectangle has side lengths of 12 and 25 if and only if its area is 300. So as a reminder, area formula is length times width. So if I said 12 times 25, does it actually equal 300? So going this direction, yes, that is true. But for that biconditional to be true, both directions have to be true. So I'm going to check the other direction. If the area of something is 300 centimeters squared, is the only thing it can be in the whole world 12 by 25? Well, no, that's false. So altogether, that is a false truth value. So I need to provide a counter example. Well, you could say 30 by 10. You could say 3 by 100. You could say 2 by 150. You could even say a 1 by 300. Lots and lots of different options. Okay? Next up, if two angles are a linear pair if and only if they are supplementary. So when we learned linear pair, that meant that they were both supplementary and adjacent. So if it's a linear pair, then yes, it must be supplementary. When we reverse it, if two angles are supplementary, did that mean it had to be a linear pair? No, it actually didn't. Because, remember, I could have this angle here that's 100, and maybe another angle over here that's 80. Do those have a sum of 180? Yes, they do. They're supplementary. But did they form a linear pair? No, they were non-adjacent. And so, as a reminder, over here, when we talked about counterexamples, we said sometimes counterexamples can be diagrams. And so this would be an example of drawing a diagram to provide that counterexample. Cool. So we're almost done. We are going to write these definitions as biconditionals. So a pentagon is a five-sided polygon. We're talking about what is the subject. The subject is a pentagon. And what do we know about that pentagon? We know that it's got 5 sides. Now, we wouldn't say a pentagon if and only if is a 5-sided polygon. We have to first talk about that noun being a pentagon. So I'm going to say a polygon is a pentagon if and only if it's 5-sided, or if and only if it has 5 sides. And then a right angle measures 90. Ooh, I think this is where I remembered that being on here. So what are we talking about? We're talking about a right angle. What do we know about right angles? We know they measure 90. So we have an angle is a right angle if and only if its measure is 90. The last thing is we can use slogans and write them as conditional statements. So anytime you've heard McDonald's, it goes ba-da-ba-ba-ba, I'm loving it. So our hypothesis is we're talking about McDonald's. Our conclusion is that we're going to say that we're loving it. So I wouldn't just say if McDonald's, then I'm loving it. I want to create it in a sentence that sounds good. So maybe if I'm eating McDonald's, then I'm loving it. And our last one is Crayola, and they say everything imaginable. So maybe if when I think of Crayola, I think of crayon. So maybe if I'm coloring with Crayola, then everything is imaginable. And that concludes everything. And then you've got your assignment you can work on. And you also picked up this. It's just like a quick reference, minding our P's and Q's. P being the hypothesis, Q being the conclusion. So if hypothesis, then conclusion. The converse switches it. If conclusion, then hypothesis. This little tilde in front is a negation. So if not hypothesis, then not conclusion. Contrapositive did both. It switches and negates. So if not conclusion, then not hypothesis. And the last thing we learned today is biconditional. Hypothesis, if and only if, conclusion. And so that's just called minding our P's and Q's, and just a quick way to reference those things we're supposed to memorize. So work on your assignment and let me know if you need any help. Thanks, bye.